here today with Mike Wesolowsky, and you've been doing acoustics and noise control and quote unquote soundproofing, which we'll get into in a minute, for a very long time. So currently with Thornton Tomasetti.
Correct.
So tell us a little bit about who you are and your experience.
I actually started off academics with did my grad work in structural dynamics, so vibration control, earthquake engineering, seismic isolation of bridges and buildings.
In Canada?
Oh yes, McMaster University. And from there I ended up into tall building wind engineering, which is basically wind earthquake causes your building to flop around, so it's basically the same phenomenon, essentially. And from there, vibration is noise and noise is vibration. So it was an easy slide laterally about 15 years ago into the world of acoustics from there. So my technical background is vibration, but, like I said, noise is vibration.
Right. So you've been doing this for about 15 years now. So I would say that qualifies you as being an expert in the category.
Yes.
We were talking a little bit about this earlier, but what type of situations are you typically called into for reviewing sound issues, whether it's post-construction, pre-construction? Tell us a little bit about your day-to-day.
It's a good combination of both. Both new design from, we'll be part of a team working with the architect and the mechanical and structural, electrical, and all these other sub-consultants, and acoustics is in there most of the time. Working on a large number of projects from residential, commercial, institutional, healthcare, laboratories, churches, city halls, like you name any large building, any building really, but any large building typically has an acoustic consultant involved in the design team. And then we provide input on things like room acoustics, into how the sound moves inside of a room, sound isolation between spaces, mechanical noise control, and environmental noise and vibration control as well. So that's the design side. The flip side of that, or the complementary side, I should say, is the investigative kind of work, where we'll get oftentimes it's a phone call, just comes in cold phone call. Sometimes it's with established relationships with, say, property managers, for example, of condominiums or other commercial real estate.
So larger buildings, though. Not
we get calls from John Q. Public as well.
Okay.
My neighbor's pool pump is annoying me. Can you fix that? We've got some very strange calls about. One guy called us, said that the security company of the wind turbine that was close to his house was firing vibration rays at him while he was sleeping or on the toilet. We declined to take his business, just saying. But oftentimes we get these calls. I live in a property manager will say that one of our tenants or one of our owners in the penthouse suite or even any other suite can't sleep because there's a noise, something's vibrating, the bed's vibrating, that sort of thing. So then we'll go out, and typically a lot of those cases are due to mechanical noise issues, where some pump or chiller or something has either not been isolated properly in the first place, or has failed over time. The isolation system has failed. And so you end up with a hard connection between the mechanical unit and the rest of the structure, and now you have a structure-borne noise / vibration problem. And maybe it is a partition airborne issue that does happen as well. It might be, for example, a partition that goes up to a window mullion is not well sealed there, and there's a small gap, or then maybe there's a perimeter heating unit or something where there's actually you can physically see through it to the next unit over. So there's different pathways that noise and vibration can transfer through a building, and we get all kinds of weird complaints about that sort of thing. So that is also a large portion of our job as well.
Now, is it usually obvious? We were just talking about
us, yes.
Really? So we were just talking a little bit about, you were talking gaps, and so that's flanking basically. So sound trap paths that the sound takes to travel. But is it obvious? Is it usually a gap, or is it usually a heat pump or something causing the vibrations?
It can be a combination of things, and that's one of the challenges of acoustics. If you do have an issue where you have sound transmission problem from one space to another, and we typically get a lot of calls from offices, like we just finished our office fit out, and the CEO can hear his secretary sneezing or something. You know what I mean? Right. So it could be a combination of a number of pathways, and oftentimes the secondary or tertiary pathways aren't evident until you fix the main pathway. So sometimes it takes a couple of visits to fully get the whole situation resolved, but oftentimes it's the usual suspects, if you will. As I mentioned, window mullions are a big one. Up into plenum, I mean, typically a lot of offices these days, they just build the partitions up to the underside of the ACT.
Right.
And then you've got this gigantic plenum up space up there, 3 foot, whatever, that's just wide open. So you've got the world's best wall with a gaping hole on top of it. And somehow this does not register as being a concern for people. I mean, there's ways to do, the best way to deal with that is to build your wall all the way up to the underside of the deck. But that often doesn't happen for a number of logistical reasons and cost reasons. So there's ways to sort of plug that hole in the top as well using other products that can be put in after the fact to sort of simulate that the wall is continuing without actually constructing a full wall up there.
We'll talk about this in a second because I'm curious on your take on it. But there's a lot of misconceptions about soundproofing, ductwork being one of them, or outlets. And people say there's no point in doing anything for soundproofing if you have a gap. What's your opinion on?
Well, first of all, I'm going to pick on the word soundproofing.
Yes.
Soundproofing is only possible in the vacuum of space when there is no air.
So we talk about soundproofing, and you're 100% right. So we talk about soundproofing because it's what everyone calls it, but it's sound mitigation is what it is, or sound transmission.
Transmission. Yeah, exactly.
But you're right, 100%.
Soundproofing. I mean, soundproof. You want to basically reduce it to a level that's acceptable for whatever the intended purpose is, right?
Right.
So if you're in an office setting like this, for example, I just don't want to hear, and I hear murmurs coming from next door, but I can't hear what they're saying. I can't make out what they're saying. It's okay.
It's enough.
It's enough, and we've got sound masking.
Right.
In here too, which helps to bring out the background noise, which helps to cover up some of that as well.
A lot of people don't think of that, but I worked in an office myself that same thing. You have the fan on the furnace running constantly, have it up a little bit higher. Background noise, especially in office situations.
Can cover up, So that's a combination of the two in an office setting at least. Typically, most people don't have that in their homes, right?
Yeah.
Or other settings as well. I think I cut you off. You asked me about the gaps.
Yes.
So yeah, I mean, your sound transmission quality of a partition, floor, ceiling, wall, whatever, is only as good as the weakest link to the most part. It does depend on the relative ratios of what is the weak link compared to the overall size of the assembly. But yes, if you have a pretty significant flanking pathway, you can have a very, very nice wall, and it would be a waste of money.
So let me reword this, because that's actually the term I always use, is your soundproofing is only as good as the weakest link. But ductwork, if someone has ductwork, say they've got an up-down duplex, central furnace, central heat, centralized air conditioning, is it worth, in your opinion, putting soundproofing materials in the ceiling to create the separation between the two spaces? See, I caught myself on soundproofing now.
So the proper way to do that is to put in some sort of Z-shaped, typically lined duct.
Right.
So the sound has now to reflect off of multiple surfaces of which they are absorptive. And so that now kills that sound pathway as a flanking pathway.
Right.
So it depends on the configuration of your ductwork, where it runs. Is it going to be lined? Is it going to be wrapped on the outside, for example, as to whether or not the sound is going to use that as a efficient flanking pathway from one space to the next.
So is it fair to say, on a typical house where you have the two trunks, intake and exhaust, or intake and heat and air conditioning out, and there are not direct paths from one room, say the basement, up to the second floor, that generally soundproofing materials can be put in the ceiling, and you can create that separation without significant modifications to the ductwork?
It really depends on the travel pathway, the distance of that travel pathway. So having to introduce more distance for it to travel from one space to the other will help with that. So that's why I say, back to your question about the house, it depends on how far it has to travel.
Right.
To a large extent.
So in general, if you have some materials or bends or anything like that helps mitigate that sound and reducing that direct path of travel is what really helps. I guess the question we get often is that, hey, I want to put a tenant in my basement, especially nowadays, whether it's a kid or an older parent, or just, a second income because housing is expensive. And they don't want to spend it has to be, if financially it has to make sense. So they don't want to put a separate heat pump in or separate the ductwork. So that's when they're coming to us asking, does it make sense for me to put SONOpan insulation, 5/8 drywall, potentially resilient channel in my ceiling, and do all this work when I still have central air conditioner and heat?
You might as well reconfigure the pathway of the HVAC if at all possible, to try to do that. Now, of course, you've always got restraints there too, because in terms of space, like, right, if you have to move your ductwork and before it was running between two joists, but now you want to move it over there. What are you going to do? You have to go under. Now you got bulkheads. It can get a bit tricky.
Yes.
It's very situational. Sure. Like you really do have to look at it.
And I think that's one of the reasons we try and make ourselves available is we may not provide a solution, but we'll at least provide the education that people understand the difference and what you have to consider when soundproofing. So we've talked about a few technical terms, STC, IIC, sound transmission class, impact insulation class. But in your words, because those are very technical, how do you explain airborne noise and impact noise to people?
Plus or minus 10 dB, most people would say is twice or half as loud.
Okay.
So that's a really big differentiator there when people can picture that a lot better than, what does plus 5 dB mean? But, plus 10 dB, so STC 50 versus STC 40, I'm generalizing a bit there. An STC 50 wall will be twice as quiet as an STC 40 wall. Twice as quiet. Like air quotes, left, right, and center. There's a lot of qualifiers there, but that's essentially that's the
in layman's terms.
Yeah, that's the layman's term of way of saying it. Yes. Back to your point or question about the STC versus IIC. So STC is airborne sound. When I make a noise, when I talk, when your TV is playing, whatever the case is, you're generating an airborne sound. You're creating pressure waves that move throughout a space. As I'm talking, I'm exciting the air particles. All the air is bouncing around in here. You can't see it, but that's what's happening.
Okay.
Those pressure waves hit a wall, they hit a window, they hit a floor, and they cause that surface to vibrate. That surface vibrates through to the other side, and the other side becomes a speaker, and it gets regenerated over there. That's how sound moves from A to B. So that's your airborne STC, is how good is that wall at resisting the pressure waves that are keep hitting it constantly, basically. So that's airborne. IIC, impact insulation class, is, as I always say, the pitter-patter of little feet. That's when you're directly striking and exciting with an impact on the floor. Only applies to floors. So a floor that might be excellent for airborne sound transmission, like a typical residential condominium construction in Toronto anyways, is a concrete floor of significant thickness depending on the size of the building. But that's more than sufficient to meet the code requirement for airborne sound transmission.
Right.
But will not meet the IIC recommendation from the code. Keeping in mind it's only a recommendation and not a requirement. So if you have a bare concrete floor with a bare concrete ceiling and somebody walks on it, it's going to be like they're right next to you. Like you really need to introduce resilience in that system. Typically, the most efficient way is to put in an underlayment under your finished floor. Actually, the most efficient way is to use shag rug, which, obviously since the 60s or 70s has not really been much of a thing. But that would absorb the impact of somebody walking. Not just walking, but also dragging furniture and kids playing and balls rolling around and dog claws.
So there you have it. Everyone install shag rugs and we won't have any issues.
I will have a job if people install shag rugs.
Now, you mentioned, though, IIC is only on floors. Yep. What about a cupboard shutting, though? Would that not be impact noise? If it's, say, a kitchen backing on in a townhouse backing onto someone's living room? Yeah,
that is. Not typically considered, and probably the first time that question's ever been asked to me. Although door slamming does come up from time to time.
Right.
That's now a complicated pathway, more so than what's typically addressed in standard approaches of either literature or testing. Nobody's ever glued an IIC tapping machine to a wall before that I'm aware of. Could happen, I guess. But yeah, I mean, if you want to deal, and it comes down often to if you're talking about like a residential multi-unit building.
Yes.
And this whole concept of, as I mentioned, twice as quiet versus, a lot of more high end and even some medium end developers now are really pushing towards this, really exceeding the code requirements for sound isolation between spaces. And that's when you're talking about typically an STC S60. 5560
that's
is typically
quite significant.
That's a factor of 2 on hearing, right? On volume, or not volume, but perceptibility for people. And that's when you're starting to talk about a separated wall, where you've got, and as I mentioned, the pressure waves hit the wall vibrates, but the wall's, drywall's stuck to a stud, stuck to drywall.
Right. Everything's connected as well.
Connected, exactly. So you cut that either by having a double stud wall or putting in, resilient channel is not quite as efficient as a double stud wall. But now you've got one side of the wall vibrating and the other one is not so much because there's no hard connection.
So you leave a 1-inch gap. And I've also heard, again, there are a lot of misconceptions out there. I've heard that anything less than a 1-inch gap doesn't decouple properly. Is that
not true? One of the yes and no, mostly no.
Okay.
The answer is, as long as it's not touching, it's fine.
Okay.
Most
so
of
you
the
can
time.
have a 1/4-inch gap,
Yes,
and it would still be
Yeah.
effective.
Now that you have issues, potential complications of constructability and quality control, did that stud go in exactly straight?
Right. And we've
maybe
seen
there's a
lumber
couple of
now, at least
spots
as a
where
1/4 inch.
yeah, it bows a little bit
Yeah.
and it touches, and then you get
Yeah.
that sort of thing. Another concern is often we've seen where they put they try to do that, but with they go stud drywall, and then a gap, and then they try to recreate exactly the same thing on the other side with a small gap in the middle. Now you have an air spring. You've got a tight, stiff, air stiff layer in there that will actually potentially make things worse. You're better off leaving that middle part open, so it's open to the air of both sides of the stud cavities.
And we get asked about this all the time, but it's really only applicable in certain situations like this, where you almost have a drum in the middle, the triple leaf effect.
Basically, yes.
And that's basically what you just described, if I'm understanding it correctly, right?
Yes. Okay. Yeah, or even one of the other bad ones is you take a resilient channel, which can be an effective tool when implemented properly, and
which is not usually.
Which is usually not the case. So you've got this wall with your neighbor. Say you live in an old townhouse or something that's been designed 50 years ago, whatever, and you don't want to rip down your layer of drywall or drip. Might even be the plaster and lath or something older like that. You just want to go get resilient channel and screw it into that and stick another layer of drywall on top of that. No, don't ever do that.
That's
Now you're introducing an air spring again.
There is an option to put SONOpan, resilient channel, and drywall on. That will still add something. The resilient channel is not nearly as effective, but we do have some testing that shows that
will help. A product like that will help to absorb some of that. We'll give it more of an absorption or more of a gap. Even if it is a product, it still is a porous product.
We always post our STC ratings. That's what governments use. That's what architects use. It's what builders require to build by. But it only measures from 125 through 4,000 hertz, which isn't even the human hearing range, and also doesn't count for anything below 125, which almost all speakers, home theater, music goes below that.
Yeah.
2 questions here. How do you address it when you do tests? And how do you measure those noises when you go in?
Well, measuring is easy. Like any typical commercial sound level meter will go down much, much lower than that, below 20 hertz typically.
Okay. Do you typically use those settings on that?
Oh, that's what's a default.
Okay.
So it's in there. When it comes to you're right, the standard definition of STC as defined in the standards, yes, is within the range you mentioned. But yes, things like mechanical equipment has a significant low frequency component. Subwoofers, etc., have significant low frequency components. By convention, we've typically in the industry, if you go with a large STC, a mechanical, for example, mechanical rooms, typically you target an STC 60 minimum, just because from experience that typical mechanical equipment, if vibration isolated, so now you're just dealing with airborne sound only,
right?
That type of wall will be sufficient. But from an analytical standpoint, the partitions that we have test data for and theoretical data for will actually have information into the lower frequency range. So if you if you measure a certain source level, whatever it is, and you've got the full spectrum of measurement, above and below STC range, you can still do the calculations as to what the impact of whatever material or assembly or whatever it is that you're trying to put up in its way to mitigate the sound.
So what is the most effective material against?
Okay. When low frequency, the challenge with low frequency is that it's actually the physical wavelengths themselves. So, and there's an equation for this based on the speed of sound and the frequency. And then you can come up with the actual physical wavelength. So for example, 10,000 hertz, which is it's an annoying, whiny, high frequency sound.
Quite high.
Something like that. If you could see those, if I just generated that tone, 10,000 hertz tone, in here using a tone generator or something, and you could see the air particles moving, you'd see them move back and forth. It's about 1.25 inches.
Okay.
Correctly. So like this, moving back and forth 10,000 times per second.
At 1.25 inches.
At 1.25 inches. Yeah. That's what the waves are doing in the air. Something like a 30 hertz, which is more of a subwoofer. That's the lower end of a subwoofer. That's more like 30 feet. That's the wavelength. Huge. Yes. Okay. So that's through your room. That's into the next room.
Right.
So the air is going like this. as a whole, right? So what's the most effective way of dealing with that is building like I think it's 36 feet if I remember correctly. The proper way is to build a 36-foot thick wall. That is the most effective way to control that low frequency, because that would basically trap your low frequency. I would
venture to say most people probably don't.
You don't want to do that. Okay, so the bigger, the thicker the wall, the better, because it traps more of that wave. So that's why I use that point to illustrate that. So the thicker the wall, the more air space in that wall, the more low frequency gets trapped in that wall.
Say people are limited to rather than feet, inches.
Well, then I would go with a heavy wall. Masonry, mass is the next one. And resilience would be the other one to try to decouple.
We've talked about many misconceptions about soundproofing. I'm curious to hear what misconceptions you often hear.
What one of my biggest bugaboos, I think, is the whole people confuse sound absorption with sound transmission loss.
Right.
More than once have I got a phone call from somebody, home studio, theater, whatever, and my neighbor's complaining. What do I do? And I said, well, you got to talk about building out your wall into a thicker, all the things we've talked about already. And when I mentioned that to them, the answer is, okay, so I can just go down and get like a 2-inch absorptive panel and stick it on the wall, and that'll work, right? No.
That's acoustics controlling the sound
within the space.
And it does obviously have a little bit of an impact because
it's small, but yes. Actually, there's been a number of times over the years where we've made recommendations on one of the design side, keeping in mind that acoustics, besides the sound, the STC 50 for condo, everything else is a guideline. It is not a code requirement, right? If a structural engineer doesn't follow code, the building will collapse and kill everybody. When an acoustic consultant, does something incorrectly, it's going to be mildly annoying for people.
Right.
There's a pretty big difference, and so oftentimes architect teams will take their chances. They don't like your recommendation because it's going to cost too much, and so they just ignore it.
Yes.
And then they'll pay you more again to come back out and provide the same recommendation that you already gave them in the first place.
And I think that's partially because sound, and this is what we talk to a lot of people about, sound is not visible, or soundproofing materials or the soundproofing of sound mitigation materials are not visible. So you don't see them. Whereas the granite countertops and the hardwood flooring, someone walks in to buy a new house and they see all that and they go, oh yeah, this is great. But the build quality and the soundproofing is not, you can't see that.
With the exception of like a concert hall, for example.
Right.
If we do our job properly, nobody notices. That's what it comes down to.
Right.
It's complaint driven afterwards. So we often don't get a thanks a lot for helping us on that project. If we don't hear anything, we know we've done our job.
No pun intended.
Exactly, yeah. Obviously, like in a high-end listening space where, if you want one of those high-end, audio spaces that are designed, like the whole purpose of the project is for listening, to a concert or whatever else, then that's what, that you feel that, you notice that, like you recognize the balance. And like, have you ever been to Kerner Hall before in Toronto?
Yes.
Yeah, it's sat in the second row, I think, for a concert once there, an orchestral concert. It's stunning. It's a stunning space, and that's primarily an acoustic space. But when's the last time you walked into a city hall and went, wow, the acoustics are fantastic in here?
There is a very famous recording studio that the Beatles actually used in England, and it's just I forget the name of the actual location of the studio, but it is world renowned for having such great acoustics in this house. And that's where they all recorded, and many famous people have recorded. And sometimes it's just the space, but often it's who's behind designing that space.
Yeah.
I've asked a lot of good questions. You've answered a lot of great answers.
I've answered some of them, yes.
You've answered all of them, but some of them with it depends, which is
acoustics is such an inexact. It's, I always say economics is a dismal science. I don't have a good phrase yet for what acoustics is, but okay, here's an interesting anecdote I often tell. So I was in New York about 10, 11 years ago in an architect's, very high-end, established, one of the old Ivy League architects of New York. And I was giving this presentation about, some of the basics of acoustics. You do it for credit, right? They need their continuing education credits, and so you bring them food and a credit, they'll let you talk to them for an hour, right? And even some of them will stay awake. Okay, so I was talking about this. So we've got some amazing tools, like computational tools that you can, like for a concert hall, for an atrium, for a classroom, for any space you want, we can model it. And we can provide a file, like an MP3 file, so that you can listen to what it's going to sound like sitting in any spot in that room due to somebody singing or speaking or whatever.
That's quite incredible.
It's fantastic. It's the cutting edge. The visuals of the pressure waves moving and it's an amazing toolkit that we have, right, for this sort of stuff. And I was demonstrating this toolkit, and I was showing the waves coming off the stage of the concert hall and all bouncing all this sort of stuff. And this old architect in the back, little glasses architect kind of guy, classic architect, puts his hand up and he says, "What is all this science you're showing me? Where's the black magic of acoustics? You guys are supposed to be artists, not engineers." So, there's a lot of stuff that happened in acoustics that nobody has seen it all, or heard it all, I guess. It's not possible. There are so many unique phenomena that have just never been experienced because of a certain combination of geometry and finishes and source levels and all these different things in a room where you're still going to be surprised about some weird thing that nobody expected, nobody could have predicted, and now you're experiencing it.
It just keeps things interesting, right?
It does, yes, that's for sure.
One way to say it anyway. Well, I think we'll leave it there because that's a very good way of ending it. Thank you very much for joining us.
Yes.